Hello, welcome everyone. Today in section of Gcse, I'm going to start indices. We'll start with the basics, we'll see what are the rules, we'll do some questions, and then we'll move on to the worksheets. Worksheets are available on Akzsi app. Link is already in the description box. You can access it. So let me start.
So indices is simply a way to simplify your calculation, simplify of writing a number. Suppose if you are multiplying 200 times, obviously the number will be way larger. You can't write it. So the best way is you can write it as 2 to the power of 100. That means why I have written 2 to the power of 100? Because I have multiplied 200 times. That's the reason. Suppose if I'm adding 200 times, so what I'll write 2 into 100 because I have added 200 times. Whereas if I'm multiplying, the best way of writing it is 2 to the power of 100. So this whole is known as what? Indices. This is your base number and this is your power. So simply why we are writing indices? To simplify our calculations as well as to simplify writing something. The simplification is what? Indices. Now when we are solving indices, because obviously suppose if you are multiplying different indices together, if you are adding different indices together, simply you are using the operations. So what are the rules that you have to follow? That's important in calculation and that we'll study here. So there are 5 basic rules that you have to keep in mind, and I can assure you that doesn't matter what type of question there will be in exam, you'll be able to do it if you know these 5 rules. That's it. First rule deals with the multiplication. When you multiply two indices together, what will happen? Suppose I'm writing a generalized way. A to the power of m is multiplied to a to the power of n. You have to keep in mind that here the base number is same. A and A. If suppose it's a to the power of m into b to the power of n, it's not applicable here because base number is totally different. If base number is same, you have to write the base number exactly and then add the powers. Power gets added in this case. When you are multiplying two different indices having the same base, the power gets added. But if the two numbers are different, base numbers are different, you can't do it like this. Say for example, it's 2 to the power of 3 into 2 to the power of 4. So base number is same. I'll write 2 as it is and power gets added 3 plus 4. Answer will be 2 to the power of 7. If it's 2 to the power of 2 into 3 to the power of 2, what I have seen generally the kids do, they multiply 2 and 3, 6 and add the powers 2 plus 2. So answer is 6 to the power 4. No, this is not correct. You can't do it like this. There is no rule. You have to solve it separately. That means if the question is 2 squared into 3 squared and there is no rule dealing with this, so I'll solve 2 squared which is 4, 3 squared which is 9 and answer will be 36. You have to solve it like this. Let's move on to the next rule. It deals with the division. A to the power of m over a to the power of n is equals to a to the power of m minus n. So what happened here? Here you have divided two different indices having the same base and in that case you subtracted it. Say for example it's 4 to the power of 3 over 4 to the power of 2. Simply the base number is exactly the same, 4 to the power of 3 minus 2 which is 1. That is 4 to the power of 1 is 4. Now suppose two different base numbers are there. 2 to the power of 3 and 4 to the power of 5. So just like I told you, I have seen the kids, they do 2 divided by 4 is 1 by 2 and they subtract the powers. No. So 2 to the power of 3 is 8 and 4 to the power of 5 is 1024. Which can simplify as 1 by 128. That will be the answer if the base numbers are different. These are the two rules. Now let me move on to the third rule. Third rule is when there is a power over another power. A to the power of m over a to the power of n. So in that case, you need to multiply the powers. A to the power of m into n or a to the power of mn. So suppose if it's 2 to the power of 3 whole to the power of 4, that means it's 2 to the power of 4 into 3, that is 2 to the power of 12. So it doesn't matter how many powers are there over each other, multiply them all together, which means if suppose it's 2 squared to the power of 3 to the power of 4. So you can see there are 3 powers now. You need to multiply them together. So 2 to the power of 2 into 3 into 4, which is 2 to the power of 24. Next is when something has a power 0, and it's the simplest one. If something has power 0, the answer is always 1. A to the power of 0 is 1. 1024 to the power of 0 is 1. Minus 1.023 to the power of 0 is 1. So any number to the power of 0 is always 1. Fifth rule deals with the negative indices. Suppose if it's a to the power of negative m. So what will happen? We can't write our final answer in terms of a negative power. So we have to convert the negative power into a positive power. And we can do it by flipping a fraction. So a to the power of negative m is actually a to the power of negative m over 1. So in order to make my power positive, I need to flip it. So 1 will go up there. A to the power of m will go down there. It was e to the power of negative m, but since I flipped it, the negative power turns into a positive power and it becomes 1 over e to the power of m. So suppose your question is 2 to the power of minus 2. So you need to flip it over 4. So this is how you can deal with the negative power. Suppose it's given as 4 over 3 to the power of negative 1. So what will happen? I need to flip it. So this will become 3 over 4 whole to the power of positive 1, which is, so we need to make the power positive, and for that we have to flip it. Now the sixth rule deals with a fractional power. If suppose it's a to the power of m, where m is a fraction. So it's suppose 4 to the power of 1 by 2. So what you need to do is we have to use the third rule, which was a to the power of m whole to the power of m. In order to simplify the fractional indices, we always have to use the third rule, a to the power of m. So 4 to the power of 1 by 2, first I have to write 4 in terms of a base number, in terms of a indices. 4 can be written as 2 squared, whole to the power of 1 by 2. Now applying this rule, a to the power of m whole to the power of n is a to the power of mn. So 2 to the power of 2 into 1 by 2, which is 2 to the power of 1. For fractional, it's not exactly a rule you can say. Rules are 5. But this one is how can you solve a fractional indices. So first you have to simplify the base number. Let me take in another example, which is 256 whole to the power of 3 by 2. So first thing is definitely I need to convert 256 into in an indices form. And for that we have to use a factor tree method. So 256, it's 2. My first prime number is 2. And then 256 divided by 2 is 128. Again, the smallest prime number which can divide 128 is 2. Divide 128 by 2 is 64. Again, the smallest prime number that can divide 64 is 2. 64 divided by 2 is 32. Again, the smallest prime number that can divide 32 is 2. 32 divided by 2 is 16. Again, 62, 2. Here, 8. 8 can be written as 2, 4. And 4 can be written as 2 into 2. So how many 2's are there? 1, 2, 3, 4, 5, 6, 7, 8. So 256 can be written as 2 to the power of 8. So every time when there is a fractional indices, you have to make your number, you have to convert your number into an index form, and then you can do it with using factor tree method. So 2 to the power of 8 whole to the power of 3 by 2. Using the third rule, 2 to the power of 8 into 3 by 2, that is 2 to the power of 12. So this is your final answer. In this way you can solve it. Now let me do some questions. These questions, these worksheets you will find on Akzsi app. I have provided the link in description box. See the first one. It's a simple one. 2 to the power of negative 1. Which rule? Fifth rule that deals with the negative indices. You need to flip it. So this will become 1 over 2 to the power of 1, that is 1 by 2 is your final answer. Next, 4 to the power of 0. That's the fourth rule, that any number to the power of 0 is 1. So 4 to the power of 0 is 1. Okay, let me move on to the next one. 4 squared over 3 to the power of 3. See, there is no rule dealing with it, having different base number, having different powers. So solve it separately. 4 to the power of 2 is 16. 4 into 4 is 16. And 3 to the power of 3, that means 3 into 3 into 3, which will give you 27. So final answer is 16 over 27. Next, 1 by 9 whole to the power of 1 by 2. It's dealing with the fractional power. So 1 over 9 whole to the power of 1 by 2 can be written as 1 over 3 squared whole to the power of 1 by 2. Or this can be written as 3 squared into 1 by 2. Okay, why I have written this? Because it's simple. Whole to the power of 1 by 2, that means 1 to the power of 1 by 2 and 3 squared to the power of 1 by 2. That's the meaning. That's why I have put it in a single bracket, because numerator and denominator have the same power. So 1 to the power of any power doesn't matter. Your answer is always 1. And 3 squared using the third rule, a to the power of m whole to the power of n is a to the power of m into n. So multiply these. 3 to the power of 2 into 1 by 2 is 3 to the power of 1. Answer is 1 by 3. Or simple, 1 by 9 whole to the power of 1 by 2 is, if you have studied the surds, if you are even aware of the basics of the surds, simply 1 by 2 is what? Root. So 1 by 9, root of 1 by 9 is 1 by 3. They haven't written in a surd form. So obviously it's an indices question. So better is we do like this using the rules. 1 by 16 whole to the power of negative 1 by 2. So 1 by 16 whole to the power of negative 1 by 2. Here the power is negative as well as a fractional power. So first thing is I have to write 16 in an indices form. So 1 over 2 to the power of 4 whole to the power of negative 1 by 2. So this will become 1 over 2 to the power of negative 2. Then what I need to do? I need to flip it. The 2 to the power of 2 will give me 4. So first, either at the beginning you can flip it or you can flip it at the end. Here it's written you have to simplify. 64 whole to the power of 3 by 2. Same simplification or dealing with the fractional indices is what? You have to convert base power into some number indices form. 64 can be written as 2 to the power of 6. Now whole to the power of 3 by 2. So 2 to the power of 6 into 3 by 2 will give you 2 to the power of 9.
So that's it for today. In the next lecture, we'll be continuing this sheet. Thanks. Stay tuned.